Hello students, welcome to the class of digital signal processing. Today we will be doing the properties of DFT. We have done three properties: linearity, then periodicity and circular time shift. So let's do with time reversal and conjugation and circular frequency shift. These will be the three that we will be dealing with today. And the next one will be multiplication and convolution. Those are a bit longer. So let's first do the small ones. The next property that we are discussing is time reversal. We have to prove this property of time reversal as we have already done in Z transform. Time reversal basically means that if you have the signal, say from here, -1, 0, 1, 1 and 2, let us say the values are like this, something. If you time reverse it, then this portion means this portion will appear on the left side of the y-axis and the left side of the y-axis will appear as the right side. So basically the y-axis is acting as a mirror. That is your time reversal. So x of n is changing to x of minus n. This is the time reversal property. So when you change this, here it is going to be 0 will remain fixed, but the 1 will be having, -1 will be having this value. There will be a value at -2 also, and in this side, only one value will be present at 1. So this becomes the time, in case of the time reversal, this happens. Now, in in the DFT case, what we are going to do with time reversal is how the reversal of time affects the DFT of the sequence. So if the DFT of xn, if the DFT of x of n is x of k, then DFT of x of minus n. Now here we have we have to write not simply minus n, but x of capital N minus n, because everything is fixed with the length of capital N. So x n minus n, the DFT of this one is going to be capital X n minus k. So this is the thing that basically you need to prove. If DFT of, then DFT of x of n minus n is x of n minus k. So let's get started with this proof. So once again, we will be doing the proving. So start with the left-hand side as usual. On the left-hand side, what we have is DFT of x of capital N minus n. Write the DFT formula for this one. That is going to be small n is equals to 0 to capital N minus 1. X of capital N minus small n e to the power minus j 2 pi k small n by capital N. This is it. Now what we need to do is we have to, as we used the substitution in time shift, same way this one you need to substitute with something else. So let capital N minus n is equal to m. Fine. Now this full thing, this DFT will change as, you are writing here as xm e to the power minus j 2 pi k small n. In the place of small n, you are going to write, it was small n, right? So in the place of small n, now you are going to write what? Capital N minus n is equals to m. So n, small n will be equal to n minus m. Fine. And here it is going to go from m equals to 0 to n minus 1. Got it? Here I have missed a capital. Now, just expand it. M equals to 0 to capital N minus 1, x of n e to the power minus j 2 pi k n by n into e to the power minus j 2 pi k. So this is minus m, right? by n. Now this part you see, these two are going to cancel. Now once it cancels, it is left to e to the power minus j 2 pi k. E to the power minus j 2 pi k, and this is equal to 1 as k is an integer. As k is an integer. Now see over here what we are left with is m equals to 0 to n minus 1. So here it was m. Xm e to the power j 2 pi k small m by capital N, since it was minus over there. So you can write it as plus m, right? Now you see over here, what we will be doing is, we will be here, over here, there is a multiplication by 1. Okay. So here you saw that it is written as e to the power minus j 2 pi k. We are writing it as 1. So what we are going to do, similar way, in a similar method, what we are going to do is, we will again re-multiply, but a small difference is there, that m is equals to 0 to n minus 1 x of m. This one is e to the power j 2 pi k m by n. And this one, we will write it as e to the power minus j 2 pi m into n by n. Now you will say, just go ahead up and see what was the problem over here, that we are having over here k, right? So this k we had to leave. So here we first did that this part is equal to 1. Now again this 1 we are substituting with a different exponential, which is having over here the same thing as small m is there, and then n by n. So how it helps is, now you can take it in this manner, m equals to 0 to capital N minus 1. So since we are writing it in a different manner, so x of m e to the power minus, if I take the e to the power minus j 2 pi by capital N and small m here, then what we are left with is capital N minus k. See, this one was minus over here and this is plus, so it is n minus k. Now, if simply you are writing the DFT of xn, what do you write? Xn e to the power minus j 2 pi k n by n. This is equal to xk, right? Now, if I write it x of n minus k, then at this place, at the place of k, I will have n minus k. This is what it is given here. So this full thing is basically capital X n minus k. And this way we have proved it. So if you reverse in time, it is going to get reversed in the Fourier domain also. And that is, the reversal will be according to this capital N. This is the first thing. So here you have to keep two things in mind. Start as usual, means whatever it is given to prove. But the major thing is that you should remember the statements, because they won't give this statement in the exam. They will just simply give you proof the time reversal property of DFT. So you need to remember this statement as well. You need to remember this statement as well. Okay. Once you remember this statement, you can at least start first. After that, whatever is inside this as the value over here, this you will take it as, substitute it to m. Finally, what is our aim is that we get a discrete DFT in this format. So we removed this n by n, that was equal to 1. This full thing e to the power minus j 2 pi k becomes equal to 1. We have already seen this thing in the previous example also. Now again we are saying that here there is a 1 and I am going to replace this 1 with e to the power minus j 2 pi. This time it's small m, which is over here, and n by n, right? That helps us because we can take all these things together and what we are left with will be k and capital N. That will make it equal to x of n minus k. That is the way we do prove the time reversal property of the DFT. Now the next property that we have to do is conjugation. So by now you must be very familiar with this conjugation thing. So whatever is there in the imaginary axis, if it is positive, that becomes negative after conjugating. If it's negative, it becomes positive after conjugating. So the statement for this again goes in the same manner. If DFT of x of n, if DFT of x of n is x of k, then always conjugation you are denoting with star. DFT of x star n is going to be x star n minus k. Now let us start to prove this. Again, we'll go by the same method. The method will be this. We will start with the left-hand side, which is given as DFT of x star n. We will write the formula for this, which will be the same as the DFT formula. Small n equals to 0 to capital N minus 1. Now the signal for us is x star n. So x star n e to the power minus j2 pi k n by capital N. Now this conjugation, you will take it outside. So for when you take this outside, n is equals to 0 to n minus 1, that time you have already in the beginning I said by conjugation we are changing the imaginary part sign of the imaginary part. So this sign is going to become positive, e to the power j2 pi k n by n, and the whole thing is under the star mark. Okay. Now next part, again the same thing like we did in the previous one, which was to take the 1 multiplied in these equations, n is equals to 0 to n minus 1. This is xn, then e to the power j2 pi k n by n into 1. Now this 1, we will substitute it with what? So what we had to prove was capital N minus k. So we will be using the same thing once again. What we are going to do is n is equals to 0 to n minus 1 xn e to the power j2 pi k small n by n into e to the power. So see, there was a minus there where we had to prove. So first, very, very important thing is that you need to remember the statements which you need to prove. E to the power minus j2 pi n by capital N, right? This is 1. This n gets cancelled, so small n will be making it always 1 because small n is an integer. Now we will take the common portion. So for taking the common portion, then n is equals to 0 to n minus 1 xn. We will write it e to the power minus j2 pi by capital N normally. Small n also you write, and then take the capital N minus k inside this bracket. Now put the big bracket and with the star sign outside. Okay. So this portion, finally, this part is what? This is the DFT of what? N minus k. So you will write x of n minus k. So now this is going to become x of n minus k, and there is a star. So it's going to become x star n minus, and this is how it is wrote. Just once again go through this. What we need to do is remember the statement. Very, very important thing. First, if you don't remember the statements, nothing is possible. So you should understand what is conjugation. So conjugation means xn will be changing to x star n, means positive imaginary part will be changing to negative, negative imaginary part to positive. Now, in case of DFT, it happens like this. X star n, the DFT of this one will become x star n minus k. Start with this, write down the formula of DFT, and then use the property of conjugation that if you take the whole thing and put the conjugate outside, this one will change to plus. That we have done. After that, this is a thing that you need to remember, or a trick that you need to remember here, that into 1 is multiplied here. So is this 1 has to be converted into a thing where we want, so that we get the proved part, whatever we want over here. So here we multiplied it with n, capital N by small n. That is going to cancel, and then it full thing e to the power minus j 2 pi small n will be 1. So by multiplying this part, we are not making any change, and this is completely valid. And after that, what we get is x of n minus t. So in the previous part, you see in the time reversal position, we had that 1 multiplied with e to the power j 2 pi k m by n, small m by n. So accordingly, as we require, so this one thing you see here, this was 1 over here. So this got multiplied with e to the power j 2 pi small m, because we needed a m here, and we had to remove this k. So previously we had removed this part with 1. If it was you have to do according to the proof that you want. So these two things. Now let's go to the circular frequency shift. Now circular frequency shift is almost like the time shift, but the proving is similar to it, but the thing is that you're doing the shifting in the frequency. So when we are shifting in the frequency, in the time axis, we are multiplying with e to the power something. So it is circular frequency shift. Circular frequency shift. First important thing is the statement of this one. So the statement says again the same thing. If the DFT of xn is equal to xk, then DFT of what? Xn into e to the power something, right? So e to the power j, let us take, we have shifted it by m. Same way here we are shifting the frequency by small m. So this is going to be converted to x of k minus m. Let's do the proving. So basically for the proof, we need to write the formula for this one. So DFT of this part, left hand side is this one. We will take this. If you take the DFT of this, it is going to be n equals to 0 to capital N minus 1 xn e to the power j 2 pi m into n by n into e to the power minus j 2 pi k n by n. Now this is very, very easy. You need to take all the common things outside and write it in the form which is similar to the formula of DFT, n equals to 0 to n minus 1 xn. So how can I write it? First write down e to the power minus j 2 pi by capital N. Now see the common part is n. So write it here. The leftover parts are k minus m, because here you have taken already the minus. So this k becomes here inside positive minus m. This is it. Now once you have written it, it's very easy to recognize that this is basically x, capital X k minus n, modulo of n. And this is how it's put. Okay, go through these, and we will be doing the multiplication and convolution property in the next class. Those two are a bit long, so together I have clubbed them. Thank you, everyone. Let's meet in the next class.